Hello everyone and welcome to today's video. In this session, we are going to drive an important topic, diabetic patient dataset. In this dataset, we are explore real-world dataset and analyze some key factors and making some visualization predictive modeling. So first we have to import the library which are necessary for this dataset. Import pandas as a PDF, import numpy as a NP. After that we importing matplot library, seaborn, etc. After that, our next step, we have to import the data set. So using read CSV method, we import this data set. So in this data set link provided in the description box, please check out. So this is our data set. As first we analyze what is our data set. So this is the diabetic patient data set. And as we see in this data set, the age, gender, polyuria, these all are the symptoms of the diabetic patient. Yes or no. If they yes, then it is diabetic, or it is no, then it is non-diabetic patient, or it is negative. So first step we have to give the information of our data set. So it will we have to write the df.info. So it will check if we have any null values present in our data set. So it is next is a df.isna.sum. It is another method to check if it is null value present in our data set. The next is next is we have to this is our value which has been categorical. So we have to convert this into the numerical like 1 and 0. So our first is the class is our target variable is equal to df class, and it will we have to map the values. So we using map function, and it will map, there will be positive, it will map the value as a 1, and after that negative, it will be 0. So after execution, and now we see the 1 and 0, it will be converted. The next method is, here we create one feature variable and df.columns. So the meaning of that, except first and last one, fetch all the columns. So as we see the feature, and as we see the except age and last is class, it will fetch all the values in a feature variable. The next step is so we have to convert all the data in a 1 and 0. So as we use the label encoder method, so label encoder method is used for the categorical value. Suppose we have two categorical values, male and female. So we use the label encoder method. So as first we have to, from sklearn.preprocessing, we have to import that label encoder. So as we know, it will work only on two categories values. So we use this label encoding method. After that we create R is object of that label encoder. Create one for loop. In for loop we whatever values in a feature, it will iterate over the I values, and df.I, all the values stored in a I, and lr is our object, and dot fit transform. So it will fit all the values like 1 and 0. As we see, all the categories value it converted into an 1 and 0. So it is a use of the label encoder. The next step is the data visualization. The data visualization is used to visualize the data. So first we create one variable g in this sns.catplot. So in this cat plot, in a x we plot the gender, and in a y we plot the class as it our output variable, and kind, which type of the plot you have to map. So it is a bar. After that data is equal to df, means all it will uh, fetch the value, or it will call the as a df data frame g dot set s tick labels. it label our data plot as a female and male, and Y label it will plot the diabetic probability or distribution. Plt dot show. So as we see, so it more clearly see the female and male who has more diabetic addicted, as the female plot is taller as comparatively in male. So the female has more diabetic patients. Whatever visualization you have to do, first you that write the below of that code. So as I write, the bar for female is taller, including potentially higher proportion of the female with the diabetes comparatively to male in a data set. So it is easy to understand what we have to do in our data set. Now is a it for it is for gender. Now next is we do for polyuria column. Same for sudden weight loss. For every symptoms we create the plot. The next is we have to any outlier present in our data set. So we check if it is outlier. Outlier means the extreme data points are present in our data set. So first we create the num call variable and df dot select those data type who has only numerical. So num call. Simply as we have to write the code for checking if we have any outliers present in our data set. So plt dot figure what is the size of our plot. We have mentioned it. After that we create the variable plot number is equal to and we assign the value 1 using for loop, and we calling the each and every column in the num call. If plot number is less than or equal to 25, then plt dot plot the subplot, and after that box plot sns dot box plot and increasing by 1. So it will plot the as a box plot for you to identify the outlier present in our data set. The next step is separating the feature and label variable into x and y. So in x variable df.drop, we drop the column class and fetch all the values in x, and in a y we fetch only class column. So as we say, in a x all the columns are mentioned and in a y only class column. The next step is split the train and test set. So xtrain, we create the variable xtrain, xtest, ytrain and ytrain. In this we use the train test split. After that, in this x comma y comma text size will you have to give the testing 30% data. Random state is 42. So first we have to import the train test split. So we have to check the xtrain shape, xtest shape, ytrain shape and ytest. Xtrain and ytrain shape must be similar, and ytrain or ytest. So next step is we have to apply all the classification algorithm. So first is a random forest classifier. First you have to necessarily load all the library which are necessary for this data set. As we see, Now next step is checking the cross validation score of our each and every algorithm. So first we have to see the random forest classification score. RF cross is equal to cross validation score x comma y, and we have provide the CV value 5 dot mean. Print RF cross. So first validation score for random forest is as we see RFC. So it will write in this. So first random forest score is 97%. Same for check the score for support vector machine. For each and every algorithm, you have to check the cross validation score. The next step is we create the hyperparameter tuning. These are the parameters for extra trace classifier as we see. So we import this grid CHV search CV package. We create one parameter variable and we set the criteria Gaussian entropy, max feature, maximum feature. We use auto square root and the log to maximum depth 0, 10, 20, and estimators we have to set the 50, 100, 200 and 300. We create the grid CHV parameter for this RF as this parameter is used for the extract classifier. Here we max feature as we have to write the features and it will execute it. Now we have to create the final model. So final model extract classifier criteria is equal to gain a maximum date 20. These all are the features it will give, or this is the best parameter as we see. And the lastly we provide is accuracy score for final model is 100%. here we create the confusion matrix so we can able to see the actual value and predicted value for the final model. So SNS dot heatmap, it will here we use, and here we see the actual and the predicted values. After we plotting the ROC and compare the AOC for the best model, we create our ROC curve here. So whatever library which are required for this, we are imported. So plot the ROC curve, important libraries ROC curve display, it will be important. After that we plot the each and every algorithm, or as we say we plot the each and every ROC curve for this, for using dot free from estimator. So it will plot this curve, as we say that it is our 100% data, so it will plot this straight line. Now we plot for our final model ROC curve. So this is our ROC curve for final model. So this is all about this data set. Thanks for watching, guys.